Alright, let's do this problem here. It's the next one on this list. Oh. What the hell is happening? Okay, same idea is basically how far can you go? But this time, the other one was true or false. This one was what's the minimum number of jumps? So you start. So you start here, right? 2, 3, 1, 1, 4. Okay, so yeah, and then basically how many jumps? This is 2 because you can take one of this and then one of that. Minimum number of jumps to reach the last index. Okay. I was thinking maybe. Okay, so maybe we can have like. Okay, index 0, how far can it take us? It can take us to index 1 or index 2, right? Index 1 or index 2, right? I can take all of it. So that's all the outputs. For index 1, it can take me. It can take me to. It can take me to 3. Damn, but this probably will TLE though. 3, 1, 2. Damn. Okay, then this okay. 1 can take us obviously to index 0, 1, 2, 2 to 3, and 4. Then 2 will just only get us to index 0, 1, 2. So 2 will only get us to index 3. And then index 3 will only get us to 4. And then that's all the ones. But the thing is, I have to basically calculate all these numbers, find the max. So my idea was right here, 1 and 2. Does this get you to okay, I see. So does this get you to the end? No. So take the minimum jump you can here, which is going to be 1 jump. Does this take you to the end? Yes, it does. So take the maximum jump, which is 3 jump. And then return. Oh, not 3 jumps, but 1 jump. Oh, I see. Okay. Basically, like, minimize, and as soon as you find one that gets you to the end, take it. Right? Would this work here? Yeah. I see some repeated stuff. Like, I don't really care about 2 anymore, right? Because I can get to 2 with just, you know. So maybe we can, maybe it's like an interval, you know. So 1, 2, 3, 4. What if I build a range? So like, right now my range is gonna be like this, right? Starting at 0, right? My range right now is 1 through 2. Or actually, it's technically 0 to 2. Inclusive, right? Right? Then when I go to 2, then my range increases to 0 to 4. Yeah. Basically, y'all see the vision here? So I have like so I have the ranges, so this will take me to 0, 1, 2 technically, right? 0, 1, 2, but I don't think you cannot take a jump, so but yeah. And then I'll finish the range, so like the end range and the beginning range. Yeah, okay, this is good. This is good. So basically gives you a range from 0 to 2. Then in this one, we only care about the newest one, so 3, or the largest one, so 0 to 4. So I can go to 4. And if the end is there, then boom, return immediately. Yeah, I think that's a good algorithm. So like keep going until you increase the range, and we only add in new numbers. Okay, and I only care, this is like basically 2 pointers. Okay. We do start, end, 0 to 0, right? For every I in range, length of nums. We don't care about the last one because that one's pretty irrelevant. Like, that's where the goal is anyways, right? I guess target is n minus 1. Let's keep this here actually, and then we'll do and so length of nums. Okay. Basically the start is 0. End is going to equal nums of I, right? So nums of I, so it's that plus we want to do one actually less. We don't want to do the end. So end equals nums of I plus fuck. Okay, how do I calculate basically 0 to 2? So yeah, nums of I plus I. That's the maximum, both inclusive on both ends. Gotta remember that. And then we'll do jumps here. And then if jumps equals n minus 1, or target, return return n, or return jumps, and then jumps increment. Right? The start is 0, right? And then return jumps. Right? Does that make sense? I think that makes kind of sense. Like, okay. So what I'm doing here is, okay, from here I start 0. That's the maximum. So this range right now is 0 to 2. And then here is going to be 3 plus 1, which is 4. So it's going to be 0 to 4. If jumps equals, oh, no, not jumps. If end equals. Yep. Boom, return. Crap. No, that's bad actually. Make a jump here. So now right now jump 1. We've made one jump. Calculate the range, so which is 2. So it's 0 to 2. And then that's good. If end equals target, then so this doesn't, so we move on to the next one. So we made a jump, so we're now on 3, right? Calculate the end range, which is 0 to I, which is 4. End equals target, return jumps. So that's 2. Let's try it here now. 0 to 0, and then we enter, so that's 1 jump. Okay. The maximum I can go is here, which is 0, 1, 2, right? That's 2. So that actually, yep, gets me to 2. Yep, and that's not. So we go to it again. We go to 3 now. 3, and we reach again. So I think this works, yeah. At least it worked for the first 2 cases, yeah. Wrong answer. GG's, boys. Okay, let's see this one. Why this is the case. Okay, so we only want 1. I can just take 2 jumps from 3. Oh, what? Yeah, that should be 1. Why am I getting 2? Okay, let's see the algorithm here. So we'll do jumps of 1. And here is going to be 0. Wait, what? So it's going to be 0, or actually it's going to be 3 plus 0, which is 3. So it's wait, this is the always case, so I should just do this. Oh. Null? Uh-oh. Wait, what? Hold on. Wait, that's really bad. Hold on. So we have 3 here. Three plus 0, that's 3. So we basically go from 0 to 3. 0, 1, 2. That is why. Wait, 0, 1, 2. Or, okay, maybe I'm mistaken here. If the end is greater than or equal to target, because that means I can make a jump that is going to make it here. I don't need this. I'm guaranteed, because since we're guaranteed this, right? Yeah. Okay, a lot better, but we'll see if this works. Okay, why is this wrong? We wanted 1, I think. Oh, 0 jumps. Well, okay, I'll just if n equals 1, return 0. It's not really a fair case, in my opinion. Yeah. Man, this is a fuck ass problem. We needed 3, but we got 4. Okay. See the algorithm here. So we have 1. Okay, we have target. So we're saying it's 4 jumps? Interesting. Or maybe I should put this at the end. Okay, I need to put it at the first. Okay, so we have here bum ba dum bum 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 bum. Okay, we have here 1 2 1 1 1 1. 1 2 1 1 1. 1 2 1 1 1. Okay. Why? So we go here. The end range is going to be here. Okay, the end range is here, so it's 0 1. So it's 0 to 1. Nowhere near that. So it takes the 1 jump. Then here is going to be 1, so 3. So 1 2 3. End range is 3. Still not the case. We still have to take a jump. And then we go here. Wait, what am I missing here? Okay, maybe I should be jumping. The thing, I'm jumping way too much. Like, every jump is not necessarily true. I should do this. We should have end here. And farthest. So end is like the current range. So, okay, first is like this, right? So if farthest is, so I guess we could do this, right? Farthest equals max of farthest or nums of I plus 1. So like it's like the farthest thing we can go to right now, right? Which is 2. That's gonna be our farthest we can go with 1 jump, right? Then from there I should say if I equals end, right? Oh crap. If I equals end, then that's it. Like, we need to update end to be the farthest. That's like all the like we're already in our window. If I is already in the window of the farthest, or if end is in the window, or I guess if I is in the window of end, then we've already exhausted that. We should move on. So that's a jump, right? Then max is, okay, then we do then we update n to be the farthest, right? Farthest. And then we return jumps. Okay, so let's think about this logic here. So here 2, 0 and 0 plus 2, that's going to be 2. So for this 2 is I equal to n, I is equal to 0. Yes, so we increment 1 and we update n to be 2. So right now n is 2 and 2. Right? Like the farthest we've gone with one jump was, or X amount of jump is 2, right? Or like index 2. Next is going to be 3. So we're at index 1 actually. So farthest is 2. Nums of that's going to be 3 plus 1. That's going to be 4. So 4 overtakes. So end is going to be 2 and 4. The farthest, we can go is I is equal to 1. Or is 1 I equal to end. End is equal to right now 2. So no, not yet. So no, we skip. Now we move on. Next iteration is gonna be pretty small. So we would actually still take 4, and we're in the range of the window right now. So we then take a jump and ends equals farther. Yeah. Is this gonna work? Yeah, awesome. All right, I'll see you guys tomorrow. Peace.